In this video, we will go over the difference between accuracy and precision. This becomes very important when you go over the first lab where you pipette water. So you pipette water in the hopes of getting 10 milliliters, and you're going to use three different instruments: a glass beaker, a graduated cylinder, and a glass pipette, which is technically the most accurate way of dispensing 10 milliliters. Well, anytime you do an experiment, you don't just do it one time to see if you get 10 milliliters. I'm talking about the first lab for those of you that are taking the course. Usually what happens is that you do replicates. So you do more than one trial. Typically we do 3 to 4 replicates. So accuracy and precision is kind of like that. You do the experiment over and over again to see, and hopefully to see if you can optimize both accuracy and precision. So what's the difference between them both? So the idea here is looking at dartboards. So if you play darts, you realize that you don't just get one dart. You get maybe 3 darts or 4 darts or 5 darts. So that's replicates. You don't do an experiment once. You do it more than one time. The more you do, the better. The more replicates you do, the better. So the idea here, at least with regards to darts, is to hit the bullseye. Not just once, because that would be a fluke. So you want to hit the bullseye multiple times. So that would be what we would term accurate. Accuracy means that you're hitting the measurement, which is the measurement that you want to get, in this case the bullseye. Now translating this to your first lab, for those of you that are doing the lab, the goal is to get to 10 milliliters, no matter whether you're measuring water with the beaker, the graduated cylinder, or the pipette. You're not always going to get 10 milliliters. You'll get 9.8 milliliters. Maybe one trial you'll get 8.74 milliliters. So henceforth we do replicates. So part A here is what we're going to call accurate. Part B is not accurate because you're not hitting the bullseye, but you are getting reproducibility. So in this case, we talk about the term precision. Precision means that every trial you do, every replicate you do, it's hitting the mark, but it's not hitting the correct mark. So translating this to the experiment with measuring water, lab 1, you're getting not 10 milliliters, which is the target, but you're getting 7.50 milliliters, 7.30 milliliters, 7.16 milliliters. So you're always getting the same amount, but you're not getting the right amount. So we call this precise. Part B is precision, but not accurate. Part A is the best of both worlds because you see you're accurate, you're hitting the bullseye, plus you're doing it multiple times. So this is real talent. That means you know how to measure water. That means you know how to play darts. So we have best of both worlds here where you're accurate and precise. So part C is the worst of both worlds. Part A is the best of both worlds. Part B is good, but usually what happens in part B is that the instrument may be off. Maybe your glass pipette is not calibrated right. Maybe something is wrong with going to more expensive instrumentation. That's where you really have to look at the instrumentation. But part A is where the instrumentation is good and you're good. Part B is probably you're good, your hands are good, but the instrumentation is bad. And part C could be a wide array of things that have gone wrong. Maybe you're just not good at measuring water, you're not good at measuring the experiment, and you're not precise, meaning that the instrument could be way off as well.